this is the LCD and it displays the current time and shows the status of the feeder, such as waiting, feeding, and when feed is done. Also, we have manual feed bottom here. This yellow bottom. This is the manual feed bottom. When I press it, or when anyone press it, the system immediately releases food for the pet, and regardless the scheduled feeding time. We have our LED, which is at the bottom here, and this LED indicates the feeding process is taking place. So it turns on while the feeding is being fed and turns off when feeding is completed. We have our food container here, and this stores the pet food before it is released. We have our shovel motor under it, and this is our actuator which controls the opening and closing mechanism of that releases the food. And we have our shaft under it, and that dispense the food, and that is our dispenser mechanism. And it is the shaft that is connected to the shovel mechanism. When the shovel rotates, it moves the shaft to open the feeding mechanism and allow the food to come out. And that's what I did, and it's working perfectly as we expected. Our pet feeding container is down here, and this is the feeding container where the food is collected for the pet to eat from it. And also, when we open the enclosure, this is our ESP32 divkit V1, and this is the main microcontroller. It controls the shovel, the LED, the push button switch, the LCD, the RTC, and it also provides Wi-Fi connection for our Blinks app connection, which is our dashboard. We have our RTC, and we are using the DS3231, and that is more accurate than the 1307, so that's why I chose this. And it is a real-time clock, and it keeps track of the actual time and allows the system to feed the pet automatically at the programmed times. I did that 3 times in a day, and it will feed as well with that accuracy. If they ask of the feeding times, the current program is set to feed 4 times a day, and that was updated from the 3 times I did earlier, and now I'm making it 4 times because 3 times, pets, those are small animals that doesn't take enough, so they usually eat rapidly during the day. So I updated that, and I think that's what we should use. And we have our LED resistors, and this is the resistor connected to the LED, and it limits the current going to the LED and protects it from any damage or blow up. We have our I2C model, and this is the I2C model connected to the LCD. It reduces the number of wires needed to be connected between the LCD and the ESP32, because you need some GPIOs to control a lot of stuff. So we have the controller here who does that, and we only have to connect our communication interfaces, which is using the pins of GPIO21 and GPIO22, which is SCL, and the 21 is SDA. We have our Blink or our Wi-Fi connection as the lecturer wanted, so I used Blink. So the ES32 also connect to the Wi-Fi and Blink as well. So for Blink, I can monitor the time and see the last feeding time, see the feeding counts, and manually trigger feeding remotely from the app. As you can see, we have the time here, and it's the same time on the phone. So let's try to feed the pet from the phone, which is our dashboard. So I will tap on this button, and I hope you can see the shaft opened and the food poured out for the pet. And that's how our system works.